Hello class, good day. Welcome to our Theory of Structures practice problem. So today we will talk about cables and arcs. This is a problem or a special problem in the Hibbeler manual, Hibbeler Theory of Structures, and I want you to analyze and understand properly this problem in order for you to excel in your upcoming examinations and quizzes. Here's the problem. We are tasked to determine the tension in each segment of the cable shown in the figure. Also, to determine the dimension of height h. Okay, so we are tasked to find the tension of the following. Tension AB, tension BC, tension CD in the following cables. And we are tasked to find the height h. Now, here are my steps in order for you to answer engineering problems, whether mechanics, whether statics, whether hydraulics, whether dynamics, whether matrix analysis, whether structural design. Here are the tasks or the steps. First, you need to read and understand. Read repeatedly the problem. Next is to list down all the given. Next is analyze what you can determine from the given. What can you understood in the processes and conceptualize ideas basically. And prepare the formulas needed. And for the solve or the solution, for the actual computation begins. Okay, so you must start solving procedurally, and in order for you to complete finally at step 4 the answer, the final answers. Now, since we have already read the basic problem, the step 0, and understand the basic concepts of the problem, we are now in step 1 to understand the given. First, we have here the summary of the length. From A, B, C, and D, the straight line is equivalent to 5.5 meters. That is basically 2 plus 2 plus 1.5. And for the height or the length of A2, the bottom C, is 4 meters. Now, what else is given for us? The forces. Okay? 3 kilonewtons and 8 kilonewtons. Now, we are also to analyze this, we are to analyze the following angle, okay? At step 2, we can see here the given from the height here of 2 meters and the length of 1.5 meters, we can get the theta or the angle, okay? The angle of cable CD. So this will be used ideally later and very crucial in order for you to analyze and to understand this angle, no? So as we can see here, it's basically the arctan of 2 over 1.5, which is equivalent to 53.13 degrees. Now, you may not use this because I know you are smart people, you are smart, matatalino kayong mga bata, okay? That's why we will look also on this such that the length of 1.5 meters with the height 2 meters, what can we see here? That is a special type of triangle. The 3-4-5 triangle, okay? The right triangle. Thus, later on, we cannot, or we may not use the angle itself, but straightforward for the X and Y components of tension CD later based on this triangle. So, this is what we have understood and analyzed from the given. Next. So, as we can see here, we have already visualized at tension CD, it will be directed at a triangle or at a special triangle 3-4-5 right triangle, northeast. Thus, or 53.13 degrees, right? The angle. Okay, so here essentially, this is our free body diagram. So the forces along A, or the supports at A, the cable B, point C and point D, or the tension CD. Force B has an applied force of negative 3 kilonewtons downward, and force C has a applied force of negative 8 kilonewtons, or 8 kilonewtons downward. Now, we are to solve the problem. What can we do? Of course, we are to visualize the reactions or the tension at each cable. So, again, class, when you assume the direction of these forces, you may be wrong in the final answer. You may get a negative answer, meaning you just have to reverse the assumption. Thus, you can have a correct answer but a wrong sign. But that doesn't mean that your answer is wrong, okay? You just only have to correct your direction. So in this case, you're assuming that the tensile at cable AB is downwards. But you may also assume it upwards, either way. But essentially, let's assume it this way. For tension BC, same, downwards. And for tension CD, as we can see here, already, it was assumed upwards. Now, in order for us to assume or to get the force, we're concerned only on tension CD in this case. Summarizing forces along the y-axis will give us many unknown variables. And for x-axis, that's why I want to summarize moments at point A as our starting point. So tension CD multiplied by 2. Why do I have your cosine? Because we have the included angle, right? But then here comes our crucial. The crucial part is that we don't want to use that. As I told you earlier, in order for me to get the x component of tension CD, I can simply get this one. Okay, in this case, the tensile at CD along the x-axis, meaning this force along the x-axis, with the moment arm 2 meters, that one, will give me the x component at 3 over 5. Because the cosine of 53.13 is simply 3 over 5 from your special triangle, adjacent over hypotenuse. So I hope you understand this very important part of our analysis. And now, how about, this is positive because the reaction or the assumption of our force is counterclockwise. It will give a counterclockwise moment. Moment arm downward, force to the right. So that will be a counterclockwise moment. Now, in the case of tensile CD along the y-axis, so that will be an assumption or the moment arm 5.5 meters, meaning the total length of the moment arm multiplied by the tensile CD y component, that will be this one, the 4 over 5. So sine 53.13 is simply opposite over hypotenuse. Now, minus the following numbers. What is this? This is basically your clockwise direction or clockwise moment because of the 3 kilonewtons and the 8 kilonewtons downward. So the moment arm 3, the moment arm rather 2, okay, multiplied by the moment arm also here for the 8 kilonewtons 4. Then we have one equation with one unknown that's very basic. For tensile CD, you already get 6.79 kilonewtons. Now, summing forces at x and y along the x and y axis at point C. Now take note, we can conduct here also, class, the method of sections. That's why I am only concerned with tensile CD. Now, we already know this angle. This is 53.13. Now, how about theta? This is unknown, okay? This is unknown. This is still unknown. We have to identify that. But first, we need to summarize to get our equations. Summing forces along the x-axis is simply, what is 6.79? That is your tension CD. Okay, that is your tension CD. So 3 over 5, again, the x component of tension CD. Cosine of 53.13 is simply 3 over 5. Now, minus, what is this? Tensile BC from the, in this case, the y component of BC, cosine of, rather the x component of tensile tension BC, this arrow, cosine of theta. Now, we have only here one equation with two unknowns. That's why we need to get the summary of forces along the y-axis. So that is tension CD 6.79 multiplied by its y component 4 over 5 minus tensile BC. Correction class, this shall be sine, okay? Sorry about that. This shall be sine. Let me correct that. Escape. This is sine, okay? So we are in a live current slide, okay? So that shall be sine, okay? The y component downwards. Why is it equivalent to 8? Why is it equivalent to 8? Class. Why is it equivalent to 8? Because of the, that should be TBC minus 8. Okay, I just transpose it to the right side. So summary, we have two equations with two unknowns. Simply, TBC is 4.82 kilonewtons and with a theta of 32.3 degrees. So this is your theta. Now, summary, now let's look on section B or the point B. So method of sections again. I have the force downward at B, negative 3 kilonewtons, tension at cable AB, and the tensile at BC. So we have already identified the tensile at BC, which is 4.82 kilonewtons. So we will use it. Now, so we are to identify negative TBA, y TBA. By the way, we have here gamma, no? We have here gamma as the angle of inclination for cable AB. Now, tensile BA, y negative because to the left. Okay? Cosine meaning we are concerned also only with the x component, horizontal component. And added 4.82, your tensile BC here, multiplied by your included angle cosine 32.3. So we have already identified also that in this case. So why it turned to the right? Why now to the right in this case, tensile BC? Because it will react, okay? Law of interaction or the third law of action and reaction. So in cutting sections, the tensile at BC or at CB to the left will be equivalent to the tensile at cable BC. Take note of my terms. Cable CB to the left, cable BC to the right. So it shall cancel out. Okay, so this will be positive. So again, we have two equations with one equation with two unknowns. Thus, we need to summarize also force along the y-axis, which is essentially TBA, positive, sine of the gamma, the angle of inclination because of positive direction, minus 4.82 sine 32.3. So that will be the y component of 4.82 force of my cable BC, minus 3 kilonewtons or 3 kilonewtons downwards. So two equations with two unknowns will give me 6.90 kilonewtons with an angle of inclination of 53.8 degrees. So we're done. We're done. We're ready now to prepare the answers or to list down all the answers. So the tensile at CD, at cable CD, 6.79 for tension BC, 4.82 with an angle of inclination of 32.3, and tension BA is 6.9 kilonewtons at angle of inclination 53.8 degrees. Now, are we done? Not yet. We are to identify H. Okay? We are to identify H. And we have already identified the included angle for BA. That is 53.13 degrees. Thus, we can simply get it by simply getting tangent of 53.13 degrees is simply opposite over adjacent. So that will be the height over your 2 meters or your adjacent side. So that will be simply 2 meters times tan 53.8, and finally you get 2.74. Now, we're done. So that is our answers. Now I have a question, class. Well, this is very crucial. This is very important in order for you to maximize or your application for the cables problem. We need here just in case. I am only concerned, or the given here is, I don't have a force for point B. What if I don't have a force for point B? So this will be 0. This will be negative 8 kilonewtons, right? Okay, let me erase that. I will omit this force, okay? I will omit that force. So that will be 0 kilonewtons. What will be my reaction in this case for cable AB? For cable AB. Or that will be tensile AB. What now will be my tensile AB? Can you think about that? Well, essentially, through your method of sections, you can simply transpose or these reactions, the reactions at A, RAX, and RAY will be simply this one, the tensile at AB or the tension at cable AB. Okay, omitting this point. So you will be considering the whole length as 1. Okay? So in your FBD, that will be RAX. So let me draw the FBD, RAY. So that will, assuming to the right and to upwards. And then we have here the point at B, no point or no force, and tensile C. Our force applied, negative 8 kilonewtons downward for FC. And that will be, for point D, that will be, assuming that, okay, so, no reactions at point B. Because there will be no applied force, and you are considering that cable A, B, C as cable AC only. Okay, take note of that, class. So that will be it. Thank you all for watching this lecture, and I hope you learned something. Comment down in the video below if you have questions, clarifications, and suggestions. Message me also in Facebook if you have any comments, class. Thank you for showing up, and always remember, 80% of success comes from showing up. God bless you all.